Hey everyone, and welcome. Get ready for a super fast revision session all about the physical properties of matter. If you have a test coming up, trust me, you are in the right place. Okay, let's jump right in. So, are you ready to absolutely nail this topic? We're going to cover all the key facts you need to know so you can walk into that exam feeling totally confident and prepared. Let's do this. All right, first up, a quick-fire round of the key terms. We're talking about stuff like conductivity, melting and boiling points, density, strength, hardness, and flexibility. These are basically the building blocks we use to describe and sort all the materials in the world. So, with all these different properties flying around, how on earth do we make sense of it all? How do scientists actually organize materials into neat little groups? Have a quick think. Well, we group them based on the properties they share. It's that simple. Take a look. Metals, like the copper and wires, are awesome conductors. Then you've got ceramics. They can take a lot of heat, but they're brittle. And plastics? They're super flexible and easy to shape. See? Each group has its own special set of skills that makes it perfect for different jobs. Okay, listen up, because this is a classic exam question, one that trips up so many people. It's a really important difference to understand, so let's make sure we get it straight once and for all. Here's the deal. Mass is simply the amount of stuff inside an object. And here's the key. It never, ever changes. Your mass is the same on Earth as it is on the moon. We measure it in kilograms. Weight, though, is a totally different story. That's the force of gravity pulling on that mass. So your weight changes depending on how strong the gravity is. It's measured in newtons. So remember, mass is constant, weight is variable. Got it? Awesome. Let's move on to our next big idea, density. Put simply, density is just how much stuff is crammed into a certain amount of space. It's a super, super important property that tells us a whole lot about a material. And of course, there's a formula you've got to know. Here it is. Density equals mass divided by volume. I'd recommend burning this one into your brain. It's the essential tool for any density calculation, and you're definitely going to need it. Now, why is that formula so useful? Well, probably its most famous job is answering this very question. How can a massive tree log float, but a tiny little pebble sinks? It all comes down to density. And the rule is actually really simple. If an object is less dense than the liquid it's in, it's going to float. If it's denser than the liquid, it'll sink straight to the bottom. And what if they have the exact same density? Well, the object will just kind of hover there, suspended right in the middle. Easy as that. Okay, hold on. If the formula is density equals mass divided by volume, then we actually need to know how to find an object's volume in the first place, right? Well, for some objects, it's pretty easy. Yep, for regular shapes, like a cube, a box, or a cylinder, all you need is a ruler and the right formula. You just measure the sides, plug the numbers into the formulas you see here, and bam, you've got your volume. Piece of cake. But let's be real. The world isn't made of perfect cubes. What do you do when you have something with a weird, lumpy shape, like a rock or your house key? You can't exactly use a ruler for that. So what's the trick? We use water. This clever trick is called the volume displacement method. You just pour some water into a measuring cylinder and write down the starting volume. We'll call it V1. Then, carefully lower the irregular object into the water until it's fully submerged. The water level will rise to a new final volume, right? That's V2. The volume of your object is simply the difference between the two, V2 minus V1. It's a brilliant method that works for any shape. So, we've gone through a lot of definitions and formulas. But why? Why does any of this stuff actually matter when you walk out of the science classroom? Why should you care? Because every single thing you use is designed based on these properties. Think about it. A cooking pot is made of metal because you want it to get hot. That's high thermal conductivity. But the handle is made of plastic because you don't want it to burn your hand. That's low thermal conductivity. It's all about matching the property to the job to make sure things work properly and safely. And we can take this idea even further. Understanding these properties doesn't just help us make things that work well, it helps us make smarter choices for the entire planet. So really, the big takeaway here is that choosing materials is a huge responsibility. We have to match the property to the job, look at the evidence, and always, always think about the environmental impact. Can we use something better? It all starts with understanding the basics we've just covered. And this quote just sums it all up perfectly. It says that by matching a material's properties to what you want to use it for, you can make sure a product works well, is safe, and is built to last. That's the whole point, right there. So I'll leave you with this final thought. Just look around the room you're in right now. Your chair, your phone, a pen. Now that you've revised all this, can you find an object and think, I wonder if a different material could do that job even better? Keep asking those questions, and good luck with your revision.